Hello, this is Mrs. Dubois, and I'm going to deliver the notes for solving inequalities on a coordinate system. So, we're going to go back to the bows, entering answers on spreadsheets shared from your teacher. Remember when you sold small bows for $3 and large bows for $5 and wanted to make some money? No, don't remember? Don't worry, we did it. Okay, you want to make at least $60. So group A, come up with a combination of small and large bows that would earn you at least $60. And group B, see if you can come up with a combination of small and large bows that would earn less than $60. And then your teacher will direct you for the discussion on this. So that and that will be a class discussion. Now, determine for each inequality if the given ordered pair is a solution or not. And remember, the solution makes the statement true, where if it doesn't work, it makes it false. Okay? So we want to show the algebra, so we actually have to physically plug in points. Okay? So we have the inequality x minus 3y is less than or equal to 6, and the coordinate pair is x and y. Okay, so we're just going to plug in 10 minus 3 times 3. Is it less than or equal to 6? So we're going to, for this part right here, we're going to use PEMDAS for all the orders of operations. So it's going to be 10 minus 9 is less than 6. One more step for simplifying. 1 is less than 6. Then you're saying to yourself, is that true? Is 1 less than 6? Well, yes, it is true. So we're going to circle the yes. So the answer here is yes. For example 2, we're going to do the same thing. We're going to plug in -1 for x and 2 for y. So it'll be 2 is greater than 2 times -1 plus 5. And then again, you're using PEMDAS to solve, this side of the equation. Erase that. To solve this side of the equation, use PEMDAS. So 2 times -1 is -2 plus 5. So we have 2 is greater than -2 plus 5. Simplify a little further. Is 2 greater than 3? Is 2 greater than 3? Well, that's false. So that is a no, because that does not work. It is not a solution. There are several differences between graphing equations and graphing inequalities. So graphing equations we've been doing this year, and if you notice, right, it's a solid line, right? This is a solid line down here, and the only solutions to this equation fall on this line, all right? So all the solutions, everything that would make all the ordered pairs that would make this equation true fall on that line. But when you add an inequality, so when you have greater than or less than greater than or equal to, you open up the number of solutions potentially. So if you see here, everything shaded is a go. All these ordered pairs, all the points in this shaded region will, in fact, make this inequality true. And it holds the same for here, right? See how you have a less than sign? All right. So now the line is going to be dotted, okay? And you're going to shade the truth. Everything shaded is a solution, okay? Or any ordered pair in this colored area will make this inequality true. Okay, so now we're going to graph a few. All right, so it's your choice. You can use y equals mx plus b, start with b, then go to the slope, or you can use x and y intercepts. So we'll do a little bit of both. So number one, this inequality is already, okay, I'm sorry if I'm repeating myself for a second, but now we're going to graph inequalities on the coordinate plane. And for some of them, you're going to use y equals mx plus b. And for some, you might potentially use the x and y intercepts, okay? And we're going to do it when appropriate, all right? So the first one right here, it says y is greater than 4x minus 3. So for a minute, you want to think about this as y equals 4x minus 3. And you're in the form y equals mx plus b. So I would start by graphing at b. So, from 0, 0, you're going to go down 3 and make a dot. And then the slope is 4 over 1. So you're going to go up 4, 1, 2, 3, 4, and over 1. And then up 4, 1, 2, 3, 4, and over 1. Okay. Now, because this is greater than, there's no equals there, you're going to have a dotted line. It's harder to get it straight. Okay. I'm just double checking myself. And it's a positive slope, so we're heading up the mountain. Okay, now we're going to test out a point. So I'm going to test a point 0, 0. That's my test point. And you want to see if it's true or false. So I'm plugging in. This is my x, this is my y. 0 is greater than 4 times 0 minus 3. So 0 is greater than negative 3. Is 0 greater than negative 3? Well, that statement is true. So you're going to shade the truth. Because 0, 0 is a solution, we're going to shade above because we're shading the truth. Okay. Number 2 is in the same form of y equals mx plus b. So for a moment, pretend this says y is equal to 3x plus 1. You begin graphing at 1, go up 1, and then the slope is 3 over 1. 1, 2, 3, 1. Again, it's positive, so you want to make sure that you're going up the mountain, and 1, 2, 3. Because there's not enough room, I'm going to hit the bottom here. So now, this does have an equal sign. So it will be a solid line. And then let's test a point. Our test point is going to be 0, 0. So we're going to say 0 is greater than or equal to 3 times 0 plus 1. 3 times 0 is 0. So 0 is greater than 1. Is that true? Is 0 greater than 1? Well, that's actually false. So we're not going to shade 0, 0. We're going to shade the truth. And the truth happens to lie anywhere up here. And so you shade above the line, okay? Example 3 is in standard form, or x and y are on the same side. So you could solve it using x and y intercepts, which I might do just because for practice. So you'll have 0. When x is 0, y is negative 1. Then we can go back. All right. Now we're going to plug in 0 for y. Interestingly enough, we're going to have the same thing, okay? So now we're going to plot the points 0, negative 1, and negative 1, 0. And if you look, this is greater than or equal to, so we're going to draw a solid line down here. And now we have to test a point. And again, we're going to use 0, 0. So 0 plus 0 is greater than or equal to -1. Is 0 greater than or equal to -1? That is true. So we're going to shade the truth, which includes 0, 0, so it's above the line. Okay. Let's see. Again, this one's in standard form, example 4. It has x and y on the same side. So I'll probably use the x and y intercepts, which means I'm going to plug a 0 in for x and a 0 in for y. So let's start. 0 plus 3y is less than -6. So 3y is less than -6. When I divide by 3, alley-oop, just made a little error there. Oh, I thought that would erase it. This should in fact say equals, right? So put a little equals here, sorry about that. So this is y is equal to -2. So when x is 0, y is -2. And then let's plug in 0 for y. So we get x plus 3 times 0 is less than -6. This will give us 0, so -6. So we have the points 0, -2. I'm going to plot that one first. 0, and then down 2, and then -6, 0. 6 right there. And let me check it out. Oh, because it's less than, it's going to be a dotted line. And we're going to test out the point 0, 0. So if I put 0, 0, does that make, if I plugged in a 0 here and a 0 here, that would say 0 is less than -6. So let's see, is 0 less than -6? No, so that is false. So again, I'm going to shade the truth, and the truth is going to be down here under the line. All right, so you want to look for, you want to draw on your prior knowledge of graphing linear equations. You want to check to make sure the line is either solid or dotted, depending on the inequality. And then you want to test a point and shade the truth. All right? Okay. Have a good day.